All right. For the past few weeks, or not weeks, but the past few days, we've been talking about slope-intercept form, standard form, and point-slope form. And what's best, or what key feature is best to find given that form. Well, today we're going to talk about how to determine the X and Y intercept. In particular, we're going to talk about if we're given a graph, a table, standard form, or slope-intercept form. We can find it with point-slope form, but just in general, we won't see problems where we have to find the X and Y intercept given the point-slope form. So let's remember that when we're talking about the x-intercept, we're talking about the point where the graph crosses the x-axis. All right, and when we don't have a graph, we know that it's the value of x when y equals 0. All right, we'll come back to the y-intercept, but let's only work with the x-intercept. All right, when we're looking at this graph here, notice that our x-axis is right here. Therefore, we're looking along the graph to determine when does it cross that horizontal line, the x-axis. And it appears to happen about right here. And at this point is where x is equal to 2. So our x-intercept in this situation is 2. Or we say 2, 0. Because remember, y is 0 at the x-intercept. When we come over here to look at the table, of course, remember, we're using the definition, the value of x when y is 0. So we look along the y to see where it's 0, and it appears to happen about right here when x is 4. So our x-intercept here is 4, 0. Now with standard form, we're going to plug in for y or substitute for y 0 and then solve for x. So it becomes x minus 2 times 0 equals 12. Since this is 0, we just cancel that out and we have x equals 12, or 12, 0 is our x-intercept. All right, for the slope-intercept form, we're going to do the same thing. We're going to plug in for y, 0, and solve for x. So this becomes 0 equals 3x plus 7. All right, from here, we're going to solve for x using the inverse order of operations. So subtract 7 from each side. And then this becomes negative 7 equals 3x. Divide each side by 3. And we're left with x is equal to negative 7 divided by 3. Or we say negative 7 over 3, 0. And if we need this to be in a number, it would be like negative 2.333 repeating. But we just normally leave it in this form. So given each form, we have found the x-intercept. Now let's talk about the y-intercept, which means the point on the graph when it crosses the y-axis. All right, and remember, the y-axis is up here. That's our y. So we're looking along here to determine where does the graph cross the y-axis. Or we say the value of y when x is 0. And we'll use this definition for the table, standard form, and slope-intercept form. But for now, let's look along the graph, all right? And at what point does the graph cross this y-axis? All right, and that would be about right here. All right, and we ask ourselves, well, what number is that? Well, 1, 2, 3, 4, 5. Looks like it's about 6. So, actually, negative 6. So, our y-intercept is 0, negative 6. All right, now we're going to move to this table. And we're looking for when x is 0. Notice right up here at the top, x is 0. So we're looking for our y, which is 4. So our x-intercept is 0, 4. All right, with standard form, we're going to substitute for x 0. And then solve for y. And we're doing it based off this definition right here, the value of y when x is 0. That's why we substituted 0 right here. All right, so this cancels out. And now we're left with negative 2y equals 12. We divide each side by negative 2. And we have y is equal to negative 6. Or we just say 0, negative 6. Last problem, we substitute for x 0. So this becomes y equals 3 times 0 plus 7. Note, this cancels, and we're left with y equals 7, or 0, 7. So now we found our y-intercept for slope-intercept form, standard form, a table, and a graph.